Hello and welcome. This is Dr. S. N. Mehboob, working at Asaj University, Warangal as an assistant professor in the Department of Mathematics, School of CS and AI. Today's lecture is continuation of previous lecture. In previous lecture, we have seen how to find mean of individual data, mean of discrete data, mean of continuous data. In today's lecture, we are going to discuss about median. By the end of this lecture, you will be able to define median and explain its role as a measure of central tendency, differentiate between mean and median, and identify when median is preferred, calculate median for ungrouped data, understand cumulative frequency and its role in finding median in group data. So let's begin. So I will begin this lecture by giving you why do we need median. Sometimes median provides true value, give exact picture. So sometimes median is fairer than mean. So imagine a class of 60 students. So most of them scored between 55 and 75. So overall the class did quite well. Did quite well. So however about five students were absent or not prepared and scored only 5%. So now when we calculate mean average value, so these very low scores pull the overall average down. So even though the majority performed well, so average makes it seem like the class performance is lower than it actually is. So this can give a misleading picture. So this is where the median helps. The median is simply the middle value when all scores are arranged in order. So since most students scored well, so the middle value falls around 64%. So which truly represents the typical student's performance. So the few low scores are at the extreme end, so they did not affect the median much. So the median gives a more accurate and fair picture of class performance, while the mean can sometimes be misleading. So class score, let us take a class of 5 students. Let us take a class of 5 students. Suppose that in a class total 5 students, scores of students are 70, 68, 65, 72 and 5. So 4 students are serious, but one student is not serious. One student does not focus. So mean of marks, 70 plus 70 plus 68 plus 65 plus 72 plus 5 divided by total number of students, total 5 students. So 280 by 5, which is 56. So 56. So 56 looks like the class did poorly, but we can see here if we arrange their marks in ascending order. So in ascending order, and we find middle value. So ascending order 5, and then next 65, then 68, and then 70, and then 72, and middle value of this list is 68. So this reflects, so 68 reflects what most students actually scored. So the difference, so one student is scoring 5% dragged the mean down by 12 points, but could not move the median at all. So the median is 68%. So here we can see that median is 68% is the fairer representation of class performance The mean 56 is misleading uh, because of that one lower score. So now come to the definition of median definition of ungrouped data. So the median for ungrouped data is the middle value in a sorted data set. In a sorted data set means after arranging in descending or ascending order, we take middle value. So if the number of values is odd, so its center value is middle value. If the number is even, then it's the average. Then we take average of uh, two middle values two middle values. So if n is odd, then value at position n plus 1 by 2. And if n is even, then we take average of values at positions n by 2 and n by 2 plus 1. Now come to the example of median. So if the observations are 25, 36, 31, 23, 22, 26, 38, 28, 20, 32. So the median is calculated as follows. So what we do, first we arrange given data in ascending order from least value is 20, and then next 22, 23, 25, 26, 28, 31, 32, 36, 38. And then next we count the total number of observations, so total 10 observations. So next we find the middle two values because the number is even. Here we can see that n is 10, which is even. So we take average of two middle values. So 10 by 2 is 5. So we take fifth and sixth positions values. So fifth position we can see that 26 and next position 28. So we take average of 26 and 28. So 26 plus 28 divided by 2, which is 27. So this is median of given data. So now come to the definition of cumulative frequency. So cumulative frequency is the running total of frequencies obtained by successive adding the frequencies of a data set. It shows how many observations fall up to or below a particular value or class interval. For example, so class interval 0 to 10, 10 to 20, 20 to 30, 30 to 40, and frequencies are 5, 8, 7, 10. So cumulative frequency is 5. We take as it is 5, and then we add 5, 5 plus 8, 13, 5 plus 8, 13, and then 7 plus 13, 20, and then 10 plus 20, 30. So the cumulative frequency for the class 20 to 20 to 30 is 20. So which shows that observations are which shows that 20 observations are less than or equal to 30. So now come to the definition of median for ungrouped frequency data. So there are three steps in this method. So first we find the total frequency n and compute n by 2 and identify the value whose cumulative frequency is just greater than or equal to n by 2. So that value is the median. So here in this problem, in problem, one data is given. So a survey was conducted to record the number of hours per week students spend on online learning. So the data obtained is given as given as x hours and frequency. So task is to find median number of hours spent on online learning. So what we do, first we find n. First we find n, capital N. So what is n? N is sum of all frequencies. So we take sum of all frequencies. So sum of all frequencies is 120, and then we divide 120 by 2. So which is 60, which is 60. And then we identify whose cumulative frequency is just greater than 60. Just greater than 60, we can see that. So let us find cumulative frequency. So here cumulative frequency 8, 8 as it is, then 8 plus 10, 18, 18 plus 11, 18 plus 11, 29. Here we can see this is 29, 29 plus 16, 29 plus 16, 35, 45. It is 45, and 45 plus 60, 65, and 65 plus 25. So 90, 90 plus 15, 105, 105 plus 9, 113, 113 plus 6, 119. So we can see that 65, 65 is just greater than 60. So 65 is just greater than 60, and the corresponding data value is 5. So corresponding x value is 5. So median is 5. Now come to the definition of median class. We will use this definition, median class, in uh, in next formula. In next formula for median of continuous distribution, continuous frequency distribution. So medial class. So what is medial class? So medial class is the interval that contains the median. What is median class? So the median class is the class interval that contains the median value of group data. Median value of the group data. So steps to find the median class. So how to find median class? First step, first we find sum of all frequencies n. First we find n, and then we divide n by 2. Then we find n by 2 and identify the class whose cumulative frequency is just greater than or equal to n by 2. Similar to previous method, and then we take that class interval is the median class. So here in this example, here we can see that here first class is 0 to 10, then 10 to 20, 20 to 30, 30 to 40, and frequencies are 5, 8, 7, 10. Cumulative frequency, take 5 as it is, 5 plus 8, 13, 13 plus 7, 20, 20 plus 10, 30, 20 plus 10, 30, and we add all frequencies. So we're adding all frequencies, so sum is 30. So we divide 30. So 30 by 2, 30 by 2 is 15. So we can see that 20 is just greater than frequency. So the corresponding interval is median class. So median class is 20 to 30. So now come to the definition of median for group data. So median for group data formula is, so median is equal to L plus n by 2 minus f divided by f into h. So what is L? L is lower boundary of the median class, and small n is the total number of observations. This n is total number of observations, and f is cumulative frequency before the median class. What is f? F is cumulative frequency before the median class, and small f the frequency of median class, and h is the width of class. width of class. So now come to the first problem. First problem of median for group data. Median for group data. So here first what we do, first we find median class, because formula, let us write formula. So here l l is equal to median is equal to plus l plus l plus n by 2 minus f divided by f, this is capital F, divided by f h into h. So f is L is lower boundary of median class. So how to find median class? So first we take sum of all frequencies. So sum of all frequencies, 5 plus 10, 15, 15 plus 12 plus 8, 20, 20, 30, 30, 5 plus 5, 40. So sum is 40, n is 40, and value is 40. Divide 40 by 2. So divide 40 by 2 is 20. So we can see that 20, so 27 is just greater than 20. So median class is 30 to 40. This is median class. Median class, median class 30 to 40, and here lower boundary of the median class. So L value is 30, and H value width, here we can see that 10 to 20. So 20 minus 10 is H value is 10, and capital F is cumulative frequency before the median class. So cumulative frequency before the median class 15. So capital F is 15, and capital F is 15, and small f, what is f? F is frequency of the median class. So frequency of the median class is 12. So f is 12. So substituting all values in formula, so L is, so median is equal to L is 30 plus n by 2 is 20 minus capital F is 15 divided by small f is 12 into h is 10. So 30 plus 12 minus 15, so 5 by 12 into 10. So 50 by 12 divided by 50 by 12 divided by 50 by 12, sorry, 50 by 12, so which is equal to 34, which is equal to 34 minus 17. So median of this given data is 34.17. So now come to the problem based on missing frequency. So here one frequency is missing in this problem, and our task is to find missing frequency. Median is given, so median is 24. Median is 24. So formula of median for frequency for continuous frequency distribution. So median formula is, so median is equal to L plus n by 2 plus sorry, n by 2. So median is right here. So median is L plus n by 2 minus f, capital F, divided by small f into h. So this is median formula. So what is capital F? Capital S cumulative frequency before median class, and small f is frequency of median class, and h is width of class interval, and L L is lower boundary of median class. So first we find median class. So given that median is 24, so median lies in interval 20 to 30. In interval 20 to 30. So by definition of median class, so median class is 20 to 30. 20 to 30, this is median class. So lower boundary of median class is 20. So L value is 20. L value is 20. And here, suppose that this is F. This missing frequency is F. So, and F, what is capital F? Capital F is cumulative frequency before median class. So cumulative frequency before median class, here we can see that here cumulative frequency 5 plus 25, 30. So 30 is cumulative frequency before median class. So capital F is 30. So substituting all values, and one more thing here, sum of all frequencies. So 25 plus 5, 30, 38, 18 plus 70, 18 plus 7, so 55. So 55 plus f, 55 plus f is sum of all frequencies. So median is given, median is 24. So 24 is equal to L value. L value is 20 plus 55 plus f divided by 2. F value is 30. F value is 30 divided by f into 10 into 10 into 10. So by simplifying, we get f is equal to 25, which is missing frequency of given data. So now come to the real life examples of median. So why median in real life? So why median matters? So the median is preferred over the mean. So when data contains extreme values. So here are three powerful real world examples where the median provides the most accurate and fair picture. So first example, so let us look at this first example. So income and salary reports. So government and economic reports use median household income rather than mean income. So why? Because a few billionaires can make the average look unrealistically high. So while the median reflects what a typical family earns. So suppose that if nine people earn 20,000 per month, and one person earns 10 lakhs per month. So the mean salary is 1 lakh 18,000. So this looks high, but the people are not earning this, but most of the people are not earning this. So the median salary is 20,000, a true value. So median tells the real story. So mean can be misleading when extremes exist. So here we can see that one person is earning 10 lakhs. So one value is very high. One value is very high, while the other nine values are very low. So most of the people are earning 20,000 per month. So here we can see that mean is not giving real picture of this data. Here median is giving a true value, so 20,000 per month. Now come to the next real life example. So here real estate property prices. So median home prices are used by property portals and government housing reports because a few luxury properties can make the average price look too high. So the median tells a buyer. So what median tells? So median tells 50% homes cost less than this, 50% homes cost more than this. So shows what a middle class buyer can expect. Suppose that, so Hyderabad. So in Hyderabad, median home price gives a realistic reference for a middle class buyer, unaffected by ultra luxury flats in Banjara Hills. So the median home price, here not mean home price, here median home price gives a realistic uh, reference. So why it matters? So not affected by luxury properties, gives a true market picture, helps in better buying decisions. Now come to the next real life example of mean. So schools and universities are use median scores to assess class performance. So especially when a few very low scores, very low scores, absentees, not serious students, or very high scores drag the mean away from representing the majority. So in a class of 60 students, if most score between 55 and 70, but 5 students scored 5%, so the median score, say 64%, is fairer representation of class performance than the mean. So choosing the right measure of central tendency, so when to use median? So data is skewed, not symmetric. So we use median. So when data contains extreme values, for example, one billionaire in a salary data set, and ordinal ranked categories. For example, poor, poor, average, good, excellent. And when to use mean? So data is roughly symmetrical or normally distributed. So when data is normally distributed, we use mean, and there are no significant outliers. And we need to use it further, it in further calculation. For example, variance standard deviation. So we use mean in variance in standard deviation. So key points in a symmetric distribution: mean, median, and mode are same. So when data is symmetric or normally distributed, so mean is equal to median is equal to mode. And in a right skewed distribution, mean is greater than median is greater than mode. And in left skewed distribution, mean is less than median is less than mode. Thank you for watching. In today's lecture, we covered what the median is and why it matters. Median for ungrouped data, median for ungrouped frequency tables, median for group data, and we have seen how to find missing frequency. Thank you. Thank you for paying your attention. See you in next lecture.